Does Gemini 3 thinks better in image or text? To answer this question, I created this entire 3D chess game so I could put Gemini 3 play chess against other models using their advanced reasonings, first just using vision or screenshots of the chess field as an input. In second match, I just used text as a chess field input to the models to see the difference. And I got very surprising insights out of this experiment, which I believe you need to know them for your agentic use cases, for best practices, how and what modalities you need to use as input for these models. Let's check it out. Just around a month ago, DeepSeek released a new paper called DeepSeek OCR, which technically in this paper they're proposing a new mentality of how we should treat these large language models or multimodal models as an input instead of just focusing on text as an input. So they noted that an image worth 1,000 words. That means maybe instead of just focusing on text is the best way or think about these large language models as an input, maybe we need to shift to images, because what they did is that they said with images, let's say taking this PDF, creating some patches, they created a new model, sort of 80 million parameter model that tokenized these images to make less tokens compared to if we just take this as raw text and then ship it to the model. So they're saying that we could compress huge amount of documents in these PDFs when we represent them as an image, and we go through this modular way for tokenizing them and then doing the rest of decoding and encoding to finally get the outcome back to the user. So that sort of make a critical question is, do we need to really shift our focus on moving towards considering image as the best option to really talk and interact with language models, or better to say foundation models, or no, not for all cases? So to answer this question also, that paper really triggered my curiosity to do this test to see, for example, other models like Gemini 3 that they have also vision capabilities, are they better in image or text? And why I chose Gemini? Because as of now that I'm recording this video, Gemini 3 Pro is on the top in Arena leaderboard, and it's fairly new. It seems to be the best model in the market as of now. Well, Opus 4.5 is out as well, so these two sort of on the top competing with each other. And don't worry, I use both of them in this demo, which I'm gonna tell you interesting insights that I got from them. Not only for the text, you can see Gemini 3 is on the top, but also for vision, still Gemini 3 Pro is on the top after 2.5, even better than models like GPT-5 or O3 and even Claude Opus. So let's get into see what I use for challenge vision versus text understanding of this model. You might have seen my previous videos that I shared with you how I created this 3D chess game using Gemini 3 so I could put different models, as I can select them here to play chess, to really see their reasonings printed here, how they're making decisions on moving these pieces. And that was really interesting, a lot of shocking results. If you haven't checked that video out, definitely check, because I had an AI tournament that I was really checking to see which one do better advanced reasoning when they were playing chess among all these top models, Gemini 3, GPT 5.1, Claude Sonnet, and Opus latest versions. I will add the video link to the video description below, and I will top right of the screen as well. You can click on it and watch it out. But here what I did, I made a new upgrade. So not only just focusing on having this chess feel and information of what has been the previous movements, what pieces were as a text, instead I also added image capability as well. So for now, at the beginning I wanted to check when Opus played just with seeing chess field as an image, including previous movements of itself and opponent also as sequence of screenshots, compared to Gemini 3, again just using image. Now, how many images of past movements I want to give it to the model? Ideally, all of them. But I realized that as soon as I actually click on the start with all, it will gradually start getting out of token, extremely slow, not even feasible at all. So I had to tune that a little bit, so ended up deciding I did 6 or 3 as the historical depths. That means always the last 6 or last 3 movements will be captured in a screenshot. We'll give it to the model, so model will see this 2D picture, as you can follow my pointer, as an input, and also the same image of last, let's say 3 or here last 6 movements. So Claude Opus is seeing the chess field right now. You can see that none of them has made any movement. It's thinking to make a decision. After making decision, it will print also the reasoning on the left here as well. Alright, you can see Opus just made the first decision. It's gonna go to this route or this location in the chess field. With this reasoning, developing the knight from b1 to d3 is a natural developing move. And at the same time, Gemini took a screenshot out of the text, out of the chess field. Here you can see that here we do have the movement happened. So it's 2D, goes to the model, and Gemini is making a decision just using this image-based input to make a decision. So back and forth I'm doing that, given that it took me a lot of time. I think the match took around 1 hour, with image was extremely slow. So I want to jump into the recording of that in a fast mode, and I will see you some interesting insights that I suddenly saw when I was playing Gemini versus Opus. Alright, here's the recording. I just played the video in 5 times faster. You can see Opus was thinking, and let me actually increase the speed a little bit more. You'll see that suddenly at the middle of the game, while I was waiting, I saw this very long error message that showed Opus made a lot of illegal tries. What does illegal try mean here? If in case the model make hallucinations, that means, for example, it's gonna decide moving a chess field that is not supposed to because it's against the rules of chess, then we will tell the model back that, hey, you made an illegal move, you have another chance to fix yourself. So we retry technically. But if that retry gonna be more than, let's say, 5 times or 10 times, the app gonna crash. I think at the beginning I had around 10 or 20 retry that the model had the chance to fix itself, and it failed all of them. So look at this one. These are all illegal moves that Opus tried to make here. If you are a professional chess player, you might say, why these are illegal moves? But app suddenly failed. So I realized that maybe I need to increase the retry time, maybe to let Opus fix itself even more than 20. So I increased that to 30 times. So model can do 30 illegal moves, or tries actually, for one decision. And if, for example, in less than 30 times it figured out the right move, then we can continue the game. Here is another recording, or better say another game. So I'm gonna increase that a little bit also higher. Let me make it slow a little bit. There you go. I think you just passed it. Look at this one. Again, I got illegal moves error. This time, more than 30 times Opus made wrong decision here, and we keep telling that, hey, this is not the right decision. Retry, do your best, do your best. It couldn't figure out what's going to be the next move in a legal way that is aligned with chess rules. So lesson learned, Opus, with just considering image, is not good at all for making a chess decision based on a lot of hallucination, as image is not a good representation for Opus to make proper decision. But on the right side, Gemini, although it made some hallucinations, but I will share you more details, the number of hallucinations was not even close to Opus. So Gemini is far better in perceiving image for making a decision in this experiment. Alright, I realized that I couldn't really continue using Opus for competing against Gemini because it literally failed to finish the game, so I decided to play Gemini against Gemini just using image. Using the image of the current movement and also the history of previous last 3 movements. I couldn't increase significantly high because it was making Gemini 3 Pro extremely slow, because with image input there should be a vision encoder that is more processing time, more resources, so it takes longer for the model to respond. So I include just 3 here. You can see that Gemini 3 versus Gemini 3 is playing, so I recorded the video. I think it took around 40 minutes to have this game end to end. It was going pretty well. Let me go all the way down at the end of the game, and there you go. We're almost there. Yes, this is actually the screenshot of the game. So this one, white wins, but again, this is also Gemini. So I had now the logs of all the reasoning, all the movements, all the decisions of Gemini playing versus Gemini only using image. But in order to have a fair comparison of how Gemini does when I have both inputs using Gemini, I ran this game again, this time with just using this image base to text base, like similar previous videos I recorded, and only including the last 3 movements as text going to Gemini models. So this time, no image at all. And here's the final result. So on the left side, you have the image-based analysis when I ran this chess game versus just text as input. Well, in general, we had the game of Gemini versus Gemini only using image. it performed better. So the black one versus white one, you can see that these are the ELU rankings. Again, ELU is a metric on chess that you calculate to see how far you are compared to a beginner or a master player. Anything above, I think, 2,500, you're considered really like an expert, like a master level. But of course, this is not something you calculate just with one game, but significantly Gemini played better in image mode. But here is a critical thing. The hallucination rate of Gemini when we were using image-based input was 26%, compared to when we're using text as an input, it was just less than 1%. So that means when you're using image as an input, in this scenario for Gemini, the chance of the model getting confused with lack of understanding of what's going on with the context is considerably higher. Although you will have more precision, more reliable answer, but still, there's a greater chance that you will have false outcomes. So on the image side, the strengths are model had better spatial reasoning because they had the 2D picture of whole chess field with the pieces there. So potentially they have a better spatial understanding out of what pieces were there. But again, that might be not a good representation because we had hallucinations. And in general, it has lower ACPL. That's another, again, metric in chess. The lower, the better. And we got better ELU metric in chess compared to text. But on the other hand, we had 26% hallucination. That's significant. It couldn't distinguish legal moves reliably on the image mode, and it requires retry system because the model was keep failing. But on the text side, we had near perfect legality. We had almost no hallucination. It was reliable. So reliable understanding was there, so we didn't need to do retry so much. But we had some tactical errors. That means from a strategy perspective, and Gemini was trying to act like an expert to make strategical decisions, when it was using images, it was better compared to text. But when it make a decision in text, most likely it's not an illegal or hallucinated move. So 4 times worse precision compared to image and poor spatial understanding because there is no image input for this model. Now, this was just an experiment, but I want to a little bit expand it to come up with a conclusion or some potential best practices we can get out of it. So why image hallucinated more? Obviously, when you provide this 2D colored-based image, there is a greater chance that it might misidentify pieces, positions, or colors in screenshots. That means the chance of introducing new noises, which is not there in text, might be there in image, and it might cause the model to get confused and hallucination. So that's the first caveat. If you have a use case that you can represent your data to your AI agent both through image and text, consider that as an option. If you go with image, you might introduce non-necessary noises to your pipeline. Second, the pieces may overlap or be unclear in certain positions. This is, again, let's make it generic, not just chess. There's a greater chance in your images, especially when you reduce your resolution to make it cheaper and make the model faster processing images, you might end up having some unclear or uncertain context within the image that might confuse the model. And the third one is it must infer legal moves from pixel data. Again, the data is just pure pixel. It doesn't have any understanding of about the whole context of chess field through matrix or numbers. And images don't enforce border state validity because, again, there's no text to rely on the rules within the chess field. Now, why text play worse from tactical perspective when it wanted to make a decision to win the game? So first, text doesn't have that 2D geometric relationship between chess fields and where they are, although we are trying to provide that through text and the matrix in chess fields and pieces, but it's still that spatial understanding that comes from an image was lost. Second, it couldn't see attack patterns and piece coordination visually. It must mentally reconstruct the board from text, which was supposed to if there is no image. I mean, theoretically, it's just a conceptual thing. And missing visual patterns that guide a strong play was not there when you're using just with text. Now, in general, if you have agentic use cases that you're considering using all different type of modalities with these models, be cautious about the fact that when you provide image as an input to these language models versus text, there is a difference. When you provide text, your text then will be converted to the tokens. There's a tokenizer, and then there's a KV or key values of those tokens getting generated. Some of them will be cache, which is called KV cache. So there's a whole process of decoding and encoding. But here, When you use image, there's a secondary step, which you need to have a vision encoder that might be a secondary model by itself that can create patches out of the image, then go through the vision encoder. So that piece provides extra time, extra processing, and increase also latency. When I played the chess game for Gemini versus Gemini only using image, it was more than 1 hour compared to just text, which could be finished in 20 minutes or 30 minutes. So 2 or 3 times slower and potentially even more expensive, which is not necessary. So consider that if you have both image and text, image has that latency and cost issue. And second, if you can really provide whatever there is in image as text, go with text. Because text by itself, like considering chess field in a matrix, is sort of a compression. I'm reducing all those type of colors or screenshot of objects, the color of chess pieces in 2D. I don't need those. If I can represent them as a text in a matrix or bunch of numbers, then it might have much more better benefits of latency and reliability and less hallucinations. So maybe in your use case, reconsider if whatever you use as image is truly needed as image. If there's a spatial understanding that needs to be in place that text doesn't provide, then go with image, or potentially try to at least combine text and image. If you have both options as modality types, then you can consider to see if image with text goes better compared to just purely using text. Now in the chess game, of course, this is just one experiment for one specific scenario. I realized that if I want to play chess again, if performance for me is high priority compared to reliability, then I will go with image, because image in general had a better performance in chess. It has better spatial understanding, but I couldn't rely on it fully because it has around 26% hallucination rate. But if that equation is vice versa, I will flip it to the text-based mode and consider that in this scenario I have both options. Sometimes you don't have the option, just one input type is whatever you have for actually making a decision and moving forward with your use case. And longest story short, multimodals process visual information more effectively for spatial reasoning, but at the cost of reliability. This one sentence is really the juice of what I really tested in this experiment. So again, if you really care about a spatial understanding within the image or something that you cannot truly compress or represent through text, then consider image as a secondary modality input. Alright, that was all about this video. And again, as I noted in previous videos, I would love to welcome whoever is a professional chess player, has won competitions, come in and become my human-based player to compete against other models for potential other video, which I think gonna be really epic to have that tested with the winner model, which so far has been Gemini 3, that had extremely well performance in previous videos in chess games compared to when it played to other models. I hope you just enjoyed this video. If yes, I would appreciate if you click on like icon and make sure you share your thoughts in comment section and subscribe so you won't miss the next video.